Hello and welcome back to the channel. In this video, we will discuss about data blocks in HDFS. We will discuss about what is a data block and what is the size of a data block and what is the importance and some of the advantages of HDFS in Hadoop. First of all, let us look into the HDFS architecture here. As we discussed in the previous video, we have a master node which has a name node, and we have a slave node that has all data nodes with data blocks in it. And then these are the data blocks of a file that will be sent for storing in the HDFS file system. And these data blocks are nothing but the smaller chunks of the large file. So what is a data block? Data blocks is nothing but the small chunks a HDFS file is split into as part of storage. And blocks are nothing but physical representation of file data. And it contains minimum amount of data that can be read by API or write by API operation, which involves metadata ops managed by master node, which is a name node. And metadata consists of the name of the data block, a replicas of each data block, and the directory location where it is stored, like which data node and which rack space, and what is the exact location on the HDFS file storage. And also it will store the information about how many replicas each data block has got and what are all the locations they are stored in. So by default, HDFS data block size is 128 MB and it is changeable as per your requirement. And if you have, per suppose, 513 MB file that has to be stored in HDFS, then it will divide into 5 blocks, among which first 4 blocks are of 128 MB size and the last 1 MB will be stored as 5th block, which gives you the facility to having a file which is not exact multiple of defined size. So that is about the fixed size of data block. As HDFS stores terabytes, even petabytes of data, if HDFS block size is very small, like in kilobytes, like if suppose you have a 10 KB data block, then the file system must maintain too many data blocks for 513 MB file, which is the overhead for the name node to maintain the metadata information for the file. And the operation to read and write also gets impacted due to the smaller size of data blocks. So for having a consistency, we will give multiples of 128 MB. We will define minimum 128 MB and it can go up to any size as per your requirement. But the point you need to remember is it cannot be huge because data block is the minimum read and write size of the file at a time. So block storage cannot have too large data block because it might cause very long time for last unit of data processing to finish its work. Let us revise the name node that manages all metadata about information about the data blocks and its all details. And the next we have highlighted area of blocks within the data node 1. The Hadoop HDFS normally splits the larger file into smaller chunks of data, nothing but data blocks. And we have rack 1, rack 2 here. By default, HDFS block size is 128 MB. We have already seen, and blocks are stored into the Hadoop file system like we have in this architecture diagram. If you notice, we have replication of data block which provides fault tolerant availability, high availability of data whenever there is a one data node goes down. Let's look into the advantages of HDFS. Ability to store very large file. So Hadoop has the facility to store huge files which are even larger than the size of single disk, as Hadoop framework breaks the file into data blocks and distribute across various data nodes. The second one is fault tolerance and high availability of HDFS. Hadoop frameworks can easily replicate the blocks between the data nodes, hence fault tolerance and high availability of HDFS is guaranteed. We have discussed about this in the previous video. So for a better understanding, when there is a file, input file coming in, and we have 5 blocks of the file, like we have 5 and 3 MB, so 5 blocks will have, each data block will have 3 replicas, and first 2 replicas will be stored in one rack, and the third will be stored in the different rack. And the first 2 replicas are also on the same rack but different data nodes for high availability. Hence, when there is a data node goes down or even a one complete rack goes down, there is last third replica available on other rack space to read and write operation to be performed. It will consistently switches whichever is available as per the data node failure policies. And the third advantage is simplicity of storage management. As we have already discussed, it has a fixed data block size, so it is very easy to calculate the number of blocks that can be stored on the disk. So this gives simplicity of storage mechanism for data node. The last one we have here is simplicity of storage management. It is again due to blocks in HDFS simplifies the storage of data nodes. Name node maintains all metadata of data blocks, and HDFS data nodes does not need to concern about the block metadata like permissions and path information. So it is less overhead for data node, wherein name node takes care of all the overhead of metadata ops related details. So that is all advantages of HDFS in Hadoop. So let's now conclude. What are data blocks? Data block is the smallest unit of data in a file system. The default size is 128 MB, and you can configure the size of data block as per your project requirements also. And HDFS blocks are easy to replicate between two data nodes, and hence it provides fault tolerance and high availability. So that's all about data blocks. Thank you for watching. See you in the next video.